Martin and I are about to start module 15 on your own.
With the smolder.
Smolder at me, baby. All right, on your own, 15.1. Please read it to me.
What is the value of the equilibrium constant for the following reaction? N2 gas plus 3H2 gas is in equilibrium with 2NH3 gas.
2NH3?
Yep. The equilibrium concentration of N2 is 0.121 molarity.
Right. 0.12 molarity?
To 1.
Say again.
0.121 molarity.
0.121. Okay.
The equilibrium concentration of H2 is 0.234 molarity. And the equilibrium
0.234?
Yep.
Uh-huh.
And the equilibrium concentration of NH3 is 1.14 molarity.
1.14
Yep.
molarity. Okay. So obviously we're going to use the equation that we find on page 496, the equilibrium constant.
This is equation
says,
15.2.
Exactly. It says that it's a capital letter K as opposed to like the lowercase letter k that we were using with the rate equation. Okay. It's just, yeah, it's a mark. So K, so if we have an equation where A to the we say the K is equal to
Concentration of C to the power of C.
Concentration of C at equilibrium.
EQ at equilibrium times concentration of D to the power of D at equilibrium.
D. The concentration of D at equilibrium to the power of lowercase d.
This is complicated.
It's not really that complicated.
You know,
over the concentration of A at equilibrium.
Concentration of
to the
A
lowercase
at equilibrium
times
to the power of lowercase a times the concentration of
B at equilibrium to the
power
of
of
B.
lowercase b. Aha!
So
You
this
missed the adjective.
this makes it easy to figure out what these numbers are going to be. We just look at our coefficients. Is there a substance D? There is no substance D, so we're obviously not going to worry about it. We're just going to worry about substance C.
Cancel it away.
Yeah, so what's our equation going to look like? We're going to say that the K for this is going to equal the concentration of NH3 at equilibrium times to the power of 2, right?
Yep.
Over the concentration of N2 at equilibrium to the power of 1, right? Because the coefficient of N2 here is 1, right? Everybody understands that. Times the concentration of H2 at equilibrium to the power of 3. So what is the concentration of NH3? That's 1.14 molarity, and that's squared over concentration of N2, 0.121 molarity times H2 concentration, which is 0.234 molarity squared. So if we're going to set this up on our calculator, we can do that as long as we use our parentheses, etc. I'm going to say open parentheses. 1.14, and I'm going to square it. Squared divided by parentheses 0.121 close parentheses times 0.234 squared equals. So I get 196.151.
That's a lot more than I would have thought.
What are my units here?
Molarity.
Now let's look at that. Here I have molarity squared, and here I have molarity squared. So I'm going to cancel them out. Okay. and here I have molarity. So what's this become? This becomes 1
1 over molarity.
over molarity. So K is 196. Now, what are my correct sig digs?
3.
So I'm going to say
196, 1 over molarity is K.
what?
838.
Oh, because I didn't cube it. I should have cubed it. I wrote cube, but I didn't
I can just
square
go back
shoot.
here and put 3 instead of a 2, and that'll fix it. Boom. Now
So
we
this
got
should
it.
be 3.
Boom.
I
It's
squared this instead of cubing
838.
this.
Yeah.
So this is actually
838.
over molarity squared. 5
Yeah.
different units. Sorry, this is cubed. I made a mistake. 838 is the correct significant digits of 1 over molarity squared is our equilibrium constant. Okay? So, number 2. You can only get it right using the parentheses if you put in the right numbers. I squared it instead of cubing it. Yeah, that would have been helpful. Okay, 15.2. Again, we have K is equal to the concentration of C to the C, C to the D. This is at equilibrium, concentration of A, equilibrium to the A, and concentration of B at equilibrium to the B. Okay, now what? The chemist is studying the following reaction. Read it to me,
2SO3 gas is in equilibrium with 2SO2 gas plus O2 gas. If the chemist starts with 1.30 molarity SO3 and no SO2 or O2, he finds that the reaction reaches equilibrium when the concentration of SO3 reaches 0.20 molarity.
0.20 molarity. Okay.
At that point, the concentration of SO2 is 1.10 molarity, and the concentration of O2 is 0.55 molarity. What is the equilibrium constant for this reaction?
Okay, oops, sorry. So the first concentrations don't matter to us, right? Because we only want to use the concentrations at equilibrium.
Yeah.
So the K is going to be easy to calculate. We're going to say, as long as we put in the right numbers, K equals.
I'll do the calculator business this time.
Yeah, okay. So the concentration of C is SO2, right?
Mm-hmm.
So that's going to be SO2. I'm writing it all out, even though it may seem tedious, at equilibrium, times the concentration of O2 at equilibrium times the coefficient, or the exponent 1, because the coefficient is 1, divided by, there's no B, there's just an A, so it's going to be the concentration of SO3 at equilibrium to the square, right? I'm not getting any of my exponents wrong this time.
That's because I'll be...
Okay, so that's going to be, the SO2 is 1.10 molarity squared times 0.55 molarity over 0.20 molarity squared. Just confirm that I have the right numbers. 0.2 molarity. Yes. Okay.
Okay. In parentheses, 1.1 times 0.55 squared.
No, 1.10 is squared.
Doesn't matter which one is squared when
yes,
it's being
multiplied. Does. Yes, because you're not multiplying it times 0.55. and then squaring that answer. Look, please look, please look. This is squared. This is not squared.
All right.
Yes, it matters very much. Here, look, if I said 2 squared times 3, right, that would be 12 versus 2 times 3 squared is 36. Do you see?
Yeah.
Okay.
17.
Yeah, 17. And what's our correct units? Molarity squared is canceled by molarity squared. We end up with molarity. So it's 17 molarity for that. 15.2.
The end of the video.
Here,
By
high
the way,
five.
I was holding my small this
High
entire
five.
time.
Yay! Let's see it. Let's see you dance. Hold on.